So I'm Tim Swanson. I'm from Cisco in the Cloud Products and Solutions group. My coworker John, we got double booked, so he's over in Service Mesh Con telling everybody about NSM in a lightning talk. So, but today, Ed alluded to it in his opening talk about we have some use cases that we've been working with NSM on, and one of them is like virtual L3 networking in a multi-cluster fashion. So I made a proof of concept, and John and I did, and and I'm going to present that and give you some, hopefully a demo, and I have a lot of slides. So if you have any detailed questions, there should be content in there that we could go through. So what is the use case here for virtual L3, for L3 networking? So a lot of folks we talk to have some model where they want, they have a type of application, maybe a stateful set like a database that they want to share between clusters and maybe even between clouds. Maybe it's just regions, but there's some cluster boundary that they want to cross. And in the past, we've done a lot of link their entire cluster subnet or VPC with a VPN and a multi-site VPN that would allow them to have any pod or any cluster talk to each other. But with NSM, we have the ability to get a really workload-centric connection between these clusters, so that only the workloads that you want to be on that VPN can be able to reach it. So what we did was we wanted to create an network service endpoint. I'm going to try to use less acronyms because it get confusing. But a network service endpoint that would provide that connectivity and be the links between them, between the network service endpoints would be provided by NSM itself. So this is the model for like a database pod wanting to join a virtual L3, what we call a virtual L3 network in NSM. They would just add an annotation on their deployment, and that for a service that provides the virtual L3 service that that their peers are also on, and they would join that virtual L3 network. So it would be like a private network between just these pods. So under the sheets, what it would look like is in each cluster, there would be a deployment of NSM and an NSE, this virtual L3 NSE, with some common way to find each other. So those NSEs need to have kind of a rendezvous point to find what other NSEs are out there that they should be connecting to, and then they use NSM to gain connectivity between each other, and then they provide the routing inter workload. So let's go through a little bit of what this really leverages the NSM Inter-domain feature. So I'm going to go through a little bit of that and try and to give some background on how this actually works. So if we're just looking at what NSM at the most basic case does is it provides a virtual wire, what I call V-wire in this diagram, between a network service client and a network service endpoint. In this case, you see that those network service client and the network service endpoint are on two different nodes. So in order to provide that virtual wire between them, there is a control plane interaction that crosses nodes by talking between, so the local workload will talk to its local network service manager, And then that network service manager will talk to the other, it'll find where the NSE is, and then talk to the NS service manager that is managing that NSE. So that's co-located with that network service endpoint. And then they will create the connection semantics, and the NSM forwarder, which Sukhdev just described in his previous talk. The flavor of his was a tungsten fabric, but the role of the NSM forwarder is to provide that virtual wire based on the connection semantics that have been worked out between the client and the network service endpoint. So when we go inter-domain, the same concept is still there. There's just some intermediaries that are domain knowledgeable. When I say domain, in this case, I'm talking about a cluster, a Kubernetes cluster, and possibly a cloud environment. So these two components are called proxy NS managers, or proxy network service managers. And what those guys' role is to act as the mechanism to connect to talk to the other control plane in the other cluster. So in this flow, you would see the workload would still just be talking to its local network service manager. That local network service manager would have an identifier of the network service that says, hey, use this proxy network service manager to connect to create your connection. And then that proxy network service manager would potentially morph the connection and figure out how to get to the other cluster, and then talk to the other cluster's proxy network service manager, and so forth. So that's the role that that's the component that knows how to connect to another control plane in another cluster. And so it's got to be, have some cloud or cluster awareness to be able to reach out of its own cluster and be maybe access a specific service that is being implemented, that is where the other proxy NS manager is. So that architecturally is the area that you could provide a lot of cloud-specific or domain-specific implementation to allow this connection to work. And then at the data plane level, the forwarder level, you would have similar semantics on, the connection semantics would be boiled into a mechanism that has been set up so that the forwarder can reach and create a tunnel to the other cluster's node network. And that is going to be an install time forwarder configuration for the NSM. So the roles of your cloud admin and your NetOps admin would be to install these NSM forwarders so that can happen, and then maybe provide some configuration to a proxy that is proxy NS manager that's implemented for that cloud type. So I just described some of this in the last slide, but this is how the data plane interaction works. So this is where it shows the role of the NSM forwarder, and after the connection semantics are negotiated, the NSM forwarder on each node in the inter-node model would actually implement the virtual wire between the workload and the NSE. In the inter-domain model, that's exactly the same. It's just more control plane interaction to work out those connection semantics. And as I mentioned before, the NSM forwarder has to be the cloud environment has to have the capability to allow the forwarder to be able to reach its peers in the other cluster. And there's a myriad of ways that could potentially happen. So on top of all that, we've been able to make a virtual L3 network service that can go internode, intercluster, and I'm going to describe what that actually, what the work involved in that is and how it functions. So if we want to recap a little bit of what a network service endpoint actually is and its responsibility in this architecture, in the sort of implementation model that falls out of that, what you see is that the network service endpoint actually consists of a portion that integrates with the NSM control plane, so it has to understand the request semantics for a connection that the network service manager provides, and it has like a data plane component. So what the function actually is that it's performing from a network service point of view. So in the case of so basically it's not responsible for making a connection, out to another workload or something like that. It's actually just handling requests and manipulating, they call it connection contexts in those requests, so that it can set up whatever protocol that it's terminating. It can communicate that to the data plane layer. And the NSM forwarder's role is to actually plug the pods, so the workload for the network service client side and the actual endpoint pod, network service endpoint pod, so that data plane function can be connected up to the workload. So for a virtual for the virtual L3 NSE, it's exactly that same model. The virtual L3 NSE is going to have it in our POC, it uses VPP as the data plane component, and it has a control plane component that understands how to create connections between the workloads. But in the slight tweak to the typical network service endpoint is that this NSE is going to have to find the other NSEs that are it's going to have to connect to, and then generate connection requests to those other NSEs, so that it can create its virtual L3 network between all of those NSEs. So it's got to tell NSM to connect this other central virtual wire between these VL3 NSEs. So that's the kind of catch to what we did in this POC, this POC. So this is a kind of eye chart thing, but hopefully it's a little bit readable. The sequence diagram that that shows the flow of how the connection is processed is shown here. And on the left side, we have the network service client, which is like the workload that wants to join this virtual L3 network. And in the middle two are the network service manager and the network service registry. For those of you who aren't familiar, the network service registry is the component that knows all of the network service endpoints in the system. And then in the next, to the second from the right, is the network service endpoint, and the NSM data plane is the furthest right. So what we see, what's the key takeaway from this in the network service endpoint connection processing is that when it's handling a network service request, it's going to have to figure out what the other network service endpoints in the system are by calling the network service registry's find network service API. And that find network service API is going to come back with a list of endpoints in that registry knows about. And then this network service, the network service endpoint is going to go through each one of those and make a connection, like a full mesh, to create a full mesh between all of the network service endpoints of the virtual L3 type. And once that's in processing those connections, it's using the connection context information to set up the L3 routing and IPAM information for terminating each one of those connections. So that's the gist of this, but there's a little bit more detail there. So one of the problems that I ran into when implementing this was IPAM. So everybody always loves that, right? This is a POC, and based on what the available implementations were, there's in the example network service endpoint SDK, there's an IPAM composite, and there's a component that you can use very easily, but it really only has the scope of, it's not a single node. So each one of these network service endpoints is actually doing their own IPAM for their connections that they're terminating. And so to avoid those guys, to make a scheme that they would allocate their own IPs, I created a global config that's a /16, and then on each of the network service endpoints, I only have one per node. I grab the third octet of the pod IP for that node, borrowing the CNI's scheme for distributing their own node IPs. I grab that. I grab a /24 with that third octet. So that attempts to, in the multi-cluster case, that's not perfect because you could have the same potential collisions on those third octets, but I haven't seen that happen, so it works okay. That's a big thing we would change in a real implementation, though. So the way that the point I think I'm making, though, is that each one of these network service endpoints has their IPAM responsibility. They have to set up the IP context for the connections that they're terminating, and that ends up involving communicating with some kind of IPAM service or managing IPAM their own, very custom way like I did. And additionally, routing is, my scheme is really kind of oriented with, I know how I want to route these things, so I used IPAM to help me do that. So in the POC details, you'll be able to see a lot of that. So I'm going to show a video for my demo. I'm not as brave as Girish. This is going to be on the public cloud, so AWS and GKE. And actually, let me go back to the slides I have. So this is the way that the topology will look after it's deployed. The AWS side they both will get deployed with NSM, and they'll have virtual L3 instances deployed in each cluster. And those virtual L3 instances will know how to find the other virtual L3 by means of me putting in an IP address to the proxy network service manager in the other cluster, and they'll be able to create connections. And then the way that I'm going to demonstrate that the databases are replicating is I'm going to use the book info application. If you guys are familiar with Istio at all, that's the common demo. There's a pod in there that's called ratings, and the application basically shows a book review with a number of stars and several a couple book reviews. And so I'll just mess with I'll have the number of stars in the database, and on the AWS side, we'll have the master database where I can write to. And on the GKE side, I'll have the slave replica database. And so I'll show that the master is replicating to the slave via that book info application, showing you changes to those number of stars. So the way where the demo flow is going to go is I'll show you that, hey, I got 2 public cloud cluster instances, one in GKE, one in AWS. I'll show how I deployed NSM in there. It's with a script using Helm charts. Then I'll show you how I deploy this virtual L3 network service endpoint in some basic config that's going on there. And then I'll show why, how the virtual L3 clients join the virtual L3 service. This is the typical pod annotation model. And then I'll show this database replication actually working. So let's go to the demo. Is that showing up? No. Okay, so this is just quickly showing that I have a cluster in Google Cloud and AWS, and then these clusters are empty. There's nothing in them before we start. So it's going to go quickly through that. So now this is where it's going to deploy NSM. So each cluster is going to get an NSM instance. And I use a script called what I called cleverly demo of VL3. So that's just using Helm charts under the sheets to set up the virtual L3, the NSM installation. So that should look familiar to a lot of you guys who use Kubernetes. So, so this is the second cluster getting the install of NSM. Not the most interesting part of the demo. So this is just going to show that, yes, things came up, and we have the proxy network service, the proxy NSMs were a part of that. So you can see these are all the pods that are in the network service NSM namespace. We have the mission webhook, the VPP forwarder, and these proxy NS managers. Those are configured so that they handle intercluster communication for the control plane. So now we're going to deploy those virtual L3 network service endpoints. And there's a call out here on the IP. So this is where I have to give the IP of the proxy so this is going in AWS. So this IP is GKE's proxy network service manager's IP for the service there. So during the installation of the virtual L3, it's going to create a config map with that IP in it, and that IP will be used in the call that is made to create the network service for the virtual L3 when it's finding network service endpoints for the other virtual L3 instances. So similarly, this is the GKE install, and it's got the IP of AWS's proxy NS manager. So the GKE instance of the virtual L3 service can find the other AWS virtual L3 instances. So this is where this is what the network service looks like. So this is the CRD for the custom resource for networks NSM and the virtual L3 services definition. And you can see I only have one network service endpoint, so all of the traffic, all the connection, all the requests are matching, and they're being consumed by this, anything with the network service mesh app label with this VL3 NSE UCNF point. So this is just showing that the network service endpoint pods are deployed with that label so that NSM knows that these are the pods terminating that or handling that service. Same thing has happened in cluster. Both clusters have the same config or same deployment scheme for this. So both clusters have instances of this network service endpoint. So this is going to show now the MySQL master installation. It's a pod on the AWS cluster, and it's going to have the annotation to join the Virtual L3 service. So here we show this annotation is for the Virtual L3 service. That's how the network service manager knows that this guy, that this this client is going to join that Virtual L3 network service. So once it comes up, so I have to grab the NSM interface's IP here because I didn't set up DNS between these, I didn't over NSM. So this is where I use that IP to tell the slave, contact this IP, this is your master is at this IP. So that's using this network service, the NSM 0 interface that is plugged by the NSM forwarder in the cluster that has the slave, in the master, I'm sorry. So now the slave is being installed. So this is MySQL, the MySQL slave, similar process, a pod is being deployed. It's got a label, an annotation that is going to be, I'm part of this Virtual L3 service. So it joins the exact same Virtual L3 network that the master is on. And the network service endpoint on its local cluster will go and reach out and find the other network service endpoint in the AWS cluster because of its configuration. And then the NSM forwarder will connect the virtual wire between the cluster, between the network service endpoints. And then this IP information is showing that I'm using that IP that I grabbed for the master in the configuration of the slave for MySQL. So once the MySQL slave comes up, I'll show that replication is working. So now it's going to, we're going to use the MySQL command line a little bit. On the left, we have the MySQL master. On the right is the MySQL slave. And so we'll do some MySQL commands to see like, hey, there's just these guys are replicating. So it's detecting the slave here. So that first line shows that the slave is actually detected. And we're going to, in the slave side, he's going to check that the master status, the slave status actually shows that it's connected to the master and is waiting for replications. So that's what that's showing, and that's the master IP. So now we're going to just look at database content, and then we're going to, on the master side, we're going to create entries in the database. So now we've created ratings entries in this database, and we're going to see that, and that database is called test, and we're going to see the database called test show up on the right side, which is the slave. So that's confirmed. And then we're going to install book info on the GKE cluster. So now book info is coming up. and it's configured to access the slave VL3 MySQL client instance, or sorry, MySQL replica. So this is just showing, it's getting the service IP for that book info page, and we're going to access that book info page here. So now you can see those stars show up because there are database entries, and then in the way that the ratings pod is installed for the book info is accessing MySQL, and that it's using that service name VL3 MySQL slave. And then I'm going to manipulate the database entries. So I'm going to modify the second review to have only 3 stars now. And then we'll go back and check the UI. Let's see if it, yep, so 3 stars show up now. Modify it again. So now what that showed is that the replication is, immediately happening between the master and the slave in the database, and we can do writes on the master side, and we have an application that's a client of the database that is in the different cluster, and it's seeing the replication. So that's pretty much it. Let's just pause that. So back to the presentation. So what did we see? What are the takeaways here? So Virtual L3 NSEs are just integrating private networking with NSM Wire connectivity. So it's not really providing the connection itself, it's just the layer 3 routing and IPAM. And then the ability to tell NSM, hey, connect me to these other, find me these other NSEs that I want to look for, that I want to connect to, and then make my connections for me. So the other unique thing about this type of NSE is that it goes and finds other NSEs. That's not a normal use case for network service endpoints. So it has to be able to access network service registries. So it has to know about which network service registries to access as well. The other key thing is that, just like any other network service in NSM, the app from the client point of view, it's just an annotation on the pod, and then NSM takes care of the rest to connect up that application to the network service. So it's very easy to have a very good separation of roles where you have a network service manager, or sorry, a network ops or cloud admin that is familiar with NSM and installing that and bringing up the virtual L3 instances, and then going and telling the clients, hey, if you want to, your virtual L3 network is available to pods with this annotation. Boom, it's done. Inter-domain connectivity, that's handled by the NSM forwarder, which is really cool because I didn't want to have to handle that in the NSE. So I get that for free because that functionality is a part of the NSM architecture and the forwarder capabilities. And that's where you can provide a lot of, like Sukhdev showed in his presentation, you can provide a lot of functionality at that data plane level, and that in your network services that are on the top of NSM just get it, right? And one of the big things there is all the transport security, your SecOps requirements can be fulfilled by an implementation of that network service manager forwarder. So NSM forwarder capability. So I have this all on GitHub. It's in a branch right now. I'm working on getting it to master. That will probably happen over the next few months or so. But this implementation is really largely based on, there's an example called the Universal CNF NSE. I've modified that, but a lot of that work key instrumental in allowing me to do this. So thanks to the NSM community for that. And thanks again to the sponsors. That's a good list there. And any questions from anybody? Yep, Nikolai?
Thanks first. That's a really great demonstration of what NSM can do for you.
Yeah.
It's so I have a couple of kind of remarks, thoughts on this, and a question. First about the IPAM, because we have struggled similar things with the CNF testbed. That's where I was mainly playing with it. I always thought that the IPAM that we have today is kind of limited to our specific use cases that we started with, the examples.
Yeah.
So I always thought that there should be kind of a, and I will refer here to Lee's presentation, this management layer on top that actually will generate the YAMLs and all these configurations for us. So use essentially the CRDs as a, okay, in your case with the universal CNF, that would be the config maps. They should be generated by some higher level that actually can see the whole picture. Otherwise, doing this by hand is a bit challenging.
Yeah. That's exactly what I think the follow-on should definitely be. I mean, I could do Helm charts or something, but something that allowed a central model more of how we. But an IPAM service or something that we could use to centralize that would be. I mean, in my opinion, that's would be
maybe a little bit more static IPs, etc., because they're a bit dynamic today, so you cannot do. Yeah. Okay, that was one thing. Then the other thing, I was really hoping, and probably we have to figure out a way to demonstrate this inter-domain, but on a lower level, because today what you're doing, I guess the replication goes over TCP.
Yeah.
Okay. It's a bit higher level. So they showed on the layer 5 on the mesh demonstration, there was this project Hamlet.
Okay.
Are you aware of it, what it does? It's essentially some kind of inter-domain stuff, but for Istio's and Linkerd there.
Yeah.
So probably it would be interesting if we can figure out an example that can do demonstrate Ethernet or something like or IP. I don't know. And then I would really invite you to join the examples. And I was looking for a long time on how to figure out to demonstrate this inter-domain on locally kind of two-kind clusters or something like this.
Yeah.
So with your experience that you more or less figured it out,
that's exactly what I want to do. I'm going to be able to get more time on NSM, but I think the part that does the essentially configures the cloud environment to allow connectivity for the data plane and the control plane. That could be we could have example implementations of those. Right now, it's built into the make files, so it's not really
it's a bit
obvious.
Complicated to figure it out. Yeah, I know.
So that's I think logically should happen soon for the to show interdomain, because and then I think there's a few warts maybe on how we expose the proxy NSM between the clusters. It's kind of like assumed to be in a certain. You can configure it, but with our Helm charts right now, it's really kind of an assumption as far as that goes, or it's really hard to figure it out without digging into a lot of the details. So,
giving an example would be great.
Yeah. I mean, it's new stuff, right? So, any other questions? Any comments? Questions? Okay. All right, that's it. Thanks.